Picture this. You pull up to a fast food drive-thru after a long day. You place your order. A robot takes it. Another robot cooks your food. And when you get home, a third robot is already waiting at your front door with your delivery. No cashier, no cook, no driver. Now here is the part that should really grab your attention. That is not a hypothetical. That is not some Silicon Valley daydream projected 50 years into the future. Pieces of that scenario are already real, already operating, already working shifts at businesses you have probably visited or ordered from. And it goes well beyond fast food. There are robots tonight patrolling office buildings and shopping malls, working through the night without ever needing a coffee break. There are robots in hospital operating rooms performing movements so precise they make the steadiest human hand look coarse by comparison. There are robots in warehouses the size of small towns, moving inventory across millions of square feet faster and more accurately than any team of human workers could. The question that sits underneath all of this, the one that nobody really wants to sit with, is a simple one. Are robots helping us? Or are they replacing us? Today, we are counting down 10 real robots that are already doing jobs that humans used to do. Some of them you have probably heard of. A few of them are going to genuinely surprise you. And by the end, you are going to have a much clearer picture of exactly how fast this shift is happening and what it might mean for all of us. Let's get into it. Number 10, Flippy, the robot that cooks your burger. We are starting in the kitchen, and specifically in the kind of commercial kitchen that most people never see, the one behind the counter at your local fast food restaurant. Flippy is a robotic cooking system developed by a California-based company called Miso Robotics, and the name, honestly, undersells what it does. Flippy does not just flip burgers, though it does that too, with a consistency that no human cook can fully match across an 8-hour shift. It uses a combination of cameras, thermal sensors, and artificial intelligence to monitor food as it cooks, detect the precise moment each item needs to be turned or removed, track temperatures across multiple cooking surfaces simultaneously, and adjust its approach in real time based on what the sensors are telling it. What Flippy never does is get tired. It never has an off day. It does not lose focus during the lunch rush when every fryer is full and 6 tickets are backed up and a manager is asking questions. It performs identically at 11 in the morning and 11 at night. Here is the thing worth sitting with though. Every fast food restaurant in the country has a kitchen. There are hundreds of thousands of those kitchens across the United States alone. If Flippy and systems like it become the standard, not a pilot program but the default, the number of cooking jobs that disappear is not a rounding error. It is a structural shift and one of the most common forms of employment available to people without advanced degrees. Number 9. Amazon's warehouse robots. If you have ever placed an order online and been genuinely surprised by how quickly it arrived, you have already experienced the downstream effect of what we are talking about here. Inside Amazon's fulfillment centers, and Amazon operates over 1,000 of them globally, a robotic workforce is running operations at a scale and speed that human workers simply cannot match. The foundation of this system traces back to 2012, when Amazon paid $775 million to acquire a company called Kiva Systems. That purchase, at the time, seemed enormous. Today, it looks like one of the most consequential investments in the history of retail. Current generation Amazon robots can sort packages by destination, lift and transport heavy inventory that would require multiple workers or specialized equipment, navigate dynamically around other robots and human employees in real time, and handle an increasing range of tasks that previously required human hands and human judgment. Some Amazon facilities now operate with tens of thousands of robots working alongside a dramatically reduced human workforce. Amazon continues to invest billions annually in warehouse automation. The direction of that investment is not ambiguous. Every dollar is aimed at reducing the number of human labor hours required to get a package from a shelf to your door. The robotic workforce in Amazon's warehouses is larger today than it was last year. It will be larger next year than it is today. Number 8. Pepper, the robot that greets you at the door. Not all of the jobs being automated involve physical labor. Some of the most common jobs in the service economy, the ones that involve standing at a counter, answering questions, and pointing customers in the right direction, are being automated too. Pepper is a humanoid robot developed by SoftBank Robotics, a Japanese technology company, and it was designed from the ground up for one specific purpose: interacting with people in customer-facing environments. Pepper is not flawless. Anyone who has interacted with one in a retail setting can tell you that it handles unexpected questions or unusual requests with a kind of cheerful inadequacy that makes its limitations obvious. But here is the thing about technology and limitations. They tend to close over time. The Pepper of 5 years from now will handle those situations better than the Pepper of today, and the Pepper of 10 years from now will handle them better still. The question for front desk and retail workers is not whether the technology is good enough right now. The question is which direction it is moving. Number 7, Nuro, the delivery robot with no seat for you. Delivery driving is one of the most common forms of employment across the developed world. It requires no advanced education. It is available at essentially any hour, and the demand for it has only grown as e-commerce has expanded and food delivery apps have become embedded in daily life. It is also one of the jobs most visibly in the crosshairs of automation. Nuro is one of the most technically advanced entries in this space. It is a self-driving delivery vehicle, but it is importantly different from the driverless car projects you may have seen covered in the news. Nuro was not designed to transport people from one place to another. There is no passenger seat. There is no space for a human occupant at all. The entire vehicle was designed around a single function, carrying cargo from one address to another without any human involvement. Walmart and Domino's have both run significant pilot programs with Nuro's vehicles. The results have been positive enough that the conversation in both companies has moved from whether this works to how quickly it can be scaled. If that scaling happens at the pace that advocates in the industry project, the number of delivery driver jobs it displaces over the next decade is genuinely large. Number 6, Vinci, the robot in the operating room. So far we have covered robots doing jobs that most people would describe as physically demanding but not particularly skilled. Cooking burgers, moving boxes, answering questions at a store counter. This one is different. The Vinci surgical system is a robotic platform used in operating rooms at hospitals around the world, assisting surgeons during procedures that require a level of precision and control that pushes at the edge of what human hands can reliably deliver. Here is how it works. The surgeon sits at a console a few feet from the patient. They look through a high-magnification 3D display showing the surgical site in real time. Their hands control input devices that translate their movements into corresponding movements of robotic arms positioned over the patient. The robotic arms hold the surgical instruments and execute the actual procedure. Vinci systems have now been used in millions of procedures worldwide, across urology, gynecology, cardiac surgery, and general surgery. The technology is no longer experimental. It is considered standard of care for certain procedure types at major medical centers. The role of the human surgeon in this system is evolving rather than disappearing, at least for now. Surgeons still plan procedures, make judgment calls, and supervise the process, but the physical execution is increasingly mediated by the robotic system. As surgical AI continues to develop, the ratio of human decision-making to robotic execution will almost certainly continue to shift. Number 5, Nightscope K5, the security guard that never sleeps. Security work is, by its nature, exhausting. Long shifts, repetitive patrols across the same corridors and parking structures, night after night. Hours of uneventful watching interrupted occasionally by situations that require fast, clear-headed responses. It is work that demands consistent attention even when, especially when, nothing is happening. The Nightscope K5 is an autonomous security robot that was designed to handle the consistent attention part of that equation. It is a 5-foot-tall, egg-shaped robot that moves on wheels at walking speed, equipped with cameras covering all directions simultaneously, thermal imaging sensors that detect body heat and movement in low-light conditions, license plate scanning technology that can flag unauthorized vehicles automatically, and artificial intelligence that monitors patterns in what its sensors are detecting and generates alerts when something deviates from what is expected. The limitation that keeps human security guards in the picture for now is response capability. The K5 detects and alerts. It does not intervene physically. When something requires a human presence, when someone needs to be spoken to, escorted, or restrained, a human still has to respond to what the robot reported. But as robotic mobility and decision-making continue to improve, even that limitation has a diminishing shelf life. Number 4, Moly, the robotic kitchen that cooks like a chef. We covered a robot that cooks burgers. Now let's talk about a robot that cooks like a trained chef. Moly Robotics, a British technology company, has developed what it calls the world's first fully automated robotic kitchen. The system consists of 2 articulated robotic arms mounted above a professional-grade kitchen setup. Stove, oven, countertops, storage, all positioned within the arm's working range. The way Moly was trained is one of the most interesting aspects of the whole project. The system's movements were not programmed the way traditional industrial robots are programmed, with engineers manually specifying every action in code. Instead, a professional chef was recorded performing complete recipes using motion capture technology, the same technology used to capture actors' movements for video games and films. Those captured movements were then translated into instructions that the robotic arms could execute. The result is a robotic system that does not just follow a recipe in an abstract mechanical sense. It follows the physical movements of an actual trained cook. The system can work from a library of thousands of recipes. It measures ingredients, handles pots and pans, adjusts heat settings, stirs and chops and combines, and when the meal is finished, it cleans up the kitchen as part of the same automated sequence. The human using it selects a recipe on a touchscreen and waits. Number 3. Starship. The little robots rolling down your sidewalk. You may have already seen these and not quite known what to make of them. Starship Technologies builds small, 6-wheeled autonomous delivery robots roughly the size of a large cooler, low enough to the ground that they share the sidewalk with pedestrians rather than the road with cars. They roll at about 4 miles per hour, which is roughly walking pace, and they navigate using a combination of cameras, GPS, and machine learning software that allows them to recognize sidewalk features, identify obstacles, and plot routes through real urban environments in real time. The operational model is simple. A customer orders food or groceries to an app. The nearest available Starship robot picks up the items from the originating business, navigates the streets and sidewalks to the delivery address, and sends the customer a notification when it arrives. The customer unlocks the insulated storage compartment remotely through the app, retrieves their items, and the robot moves on to its next assignment. Thousands of Starship robots are currently operational across college campuses, business districts, and residential neighborhoods in the United States and Europe. The company has completed millions of deliveries. This is not a test program anymore. These robots are doing real deliveries in real places for real customers every day. Number 2. Tesla Optimus. The robot built for everything. Every robot we have talked about so far was designed for a specific job in a specific environment. Flippy cooks. Amazon's robots move warehouse inventory. Pepper handles customer service. Each one is optimized for its particular task, which also means each one is limited to that task. Tesla's Optimus robot was designed around a completely different premise. In Tesla's manufacturing facilities, Optimus is already being tested performing tasks like sorting components, moving parts between workstations, and handling repetitive assembly operations that currently require human workers. The results have been encouraging enough that Tesla has publicly discussed plans to deploy Optimus robots in significant numbers within its own factories before eventually offering the product commercially. Optimus is still being developed and refined. Its current capabilities fall short of what Tesla projects for future versions, but the direction of development is clear, and the company behind it has a track record of moving faster than its critics expect. Number 1. AI call center systems, the replacement you cannot see. The number 1 spot on this list goes to a form of automation that most people encounter regularly, without fully registering that it is happening. AI-powered voice systems are replacing human call center agents, and they are doing it at a speed and scale that dwarfs everything else on this list combined. Call center work employs millions of people globally. It is one of the largest categories of white-collar employment in the world, particularly in countries like India, the Philippines, and throughout Latin America, where large English-speaking workforces have built entire regional economies around serving the customer support needs of American and European businesses. It does not require advanced education. It provides stable income, and it is being automated rapidly and systematically. For a business running a call center, the economics are transformative. An AI system can handle thousands of simultaneous calls. It does not require scheduling, benefits, paid time off, or management. It performs identically at 3 in the afternoon and 3 in the morning. Every metric that drives the cost of running a human call center either shrinks dramatically or disappears entirely when the calls are handled by AI. So let's end with a question that is genuinely worth thinking about. We have covered robots cooking food, delivering packages, patrolling buildings, performing surgery, and answering customer service calls. We have talked about humanoid robots designed to do essentially any physical job, and AI systems replacing white-collar work at scale. What comes next? What job do you think is further away from automation than most people assume, or closer to it than the people doing that job realize? Drop your answer in the comments. Those conversations are genuinely interesting, and the range of perspectives people bring to this topic is wider than you might expect. If you found this breakdown valuable, if it gave you a clearer picture of where this technology actually is right now, not where it will be someday, hit the like button and subscribe so you do not miss what we cover next, because this space moves fast, and so do we.